Integrating Uniswap into your Cartesi application may require a slight architectural adjustment depending on your use case. Uniswap is one of the earliest and most advanced DeFi applications, powering billions of dollars in liquidity and enabling a reliably large volume of transactions every single day. In this demo, alongside the standard Cartesi architecture, we introduce an additional component to interface with Uniswap. This contract is called the Vault contract. User requests are relayed through the input box to the application backend, while token deposits are transferred to the application's base layer contract via the ERC20 portal. However, unlike typical applications where deposited tokens remain idle in the application contract until withdrawal, this design takes a different approach. Here, the backend emits a voucher, which is executed on-chain by the application's base contract. This voucher transfers the deposited tokens to the Vault contract and instructs it to deploy those funds into a Uniswap liquidity pool. This allows the application to actively utilize idle funds, generating additional value while they remain available for user withdrawals. When a user requests a withdrawal, the backend once again emits a voucher. This voucher instructs the Vault to withdraw the required liquidity from Uniswap and transfer the corresponding tokens back to the user. Through this integration, applications can go beyond simple fund storage into actively participating in liquidity provision, generating yield, and even managing their own liquidity pools on Uniswap. To demonstrate this, we'll be interacting with a simple Cartesi application deployed on Base Sepolia. At the start, the application holds no tokens, and the user balance is 0 within the app, although the user has about 5,000 USDC on the base layer. We begin by approving and depositing 100 USDC into the application. This deposit is picked up by the backend and recorded accordingly, with the tokens now held by the application's base layer contract. Next, we send an input instructing the application to approve the Vault contract to spend its tokens. This step is necessary as it allows the Vault to later transfer deposited funds into a Uniswap liquidity pool. We then proceed to deposit an additional 3,000 USDC. The application is designed to emit vouchers in batches of 1,000 tokens, so this results in multiple vouchers being generated. The first set of vouchers grant the Vault approval to spend the application's token balances for both assets in the liquidity pair. Once the approvals are executed, we proceed to execute a voucher that deploys 1,000 USDC into the Uniswap liquidity pool. After refreshing the application state, we can see that the application's balance drops accordingly, from 3,100 USDC down to 2,100 USDC. Reflecting the liquidity that has been deployed. We then continue by executing the remaining vouchers, moving the rest of the funds into the liquidity pool. Finally, we initiate a withdrawal request of 1,500 USDC. In response, the application emits another voucher, instructing the Vault to remove the required portion of liquidity from Uniswap. Once executed, the Vault withdraws the necessary funds from the pool and transfers them back to the user. As a result, the user's USDC balance increases from 1,900 to 3,400 USDC, demonstrating a full cycle of deposit, deployment, and withdrawal through the liquidity pool. While this example performs a simple strategy, partially swapping USDC to USDT and adding liquidity to an existing pool, more advanced integrations can go further. Applications can manage their own liquidity pools, leverage Uniswap v4 hooks for custom logic, or even create pools tailored to their users and assets.